All right, welcome to the Explainer. Today, we're going to pop the hood on Kubernetes. We're going to build a really solid mental model of its core architecture, not just as a piece of tech, but as really a new blueprint for how modern software gets built and run.
But, before we jump into the schematics, let's start with a question to get our heads in the right space. Think about it. When our apps get as complex as a whole city with all these different moving parts, how do we actually manage all of that? I mean, who's the city planner deciding where things go? Who's making sure the power grid stays on? And who's the construction crew that rebuilds things when they fall down? That right there is the exact problem Kubernetes was designed to solve.
So here's our game plan for today. We're going to start with that big 30,000-foot view. Then we'll zoom right into the two most critical parts, the control plane, the brains, and the worker nodes, the muscle. After that, we'll see how they all work together, and we'll wrap up by talking about why any of this really matters.
Okay, let's kick things off with the big picture. You have to understand that every single Kubernetes cluster, doesn't matter if it's huge or tiny, is built on this fundamental split of responsibilities. So when you strip it all down, what is a Kubernetes cluster really? It's just two things, the brain and the muscle. You've got the control plane, which does all the thinking, all the management, and then you have the worker nodes, and they provide all the power to actually run your applications. That's it. It's that simple. Everything else we're going to talk about today fits neatly into one of those two boxes.
All right, our first stop, the control plane. This is the nerve center, the brain of the whole operation. Now, it's super important to remember, the control plane does not run your application containers itself. Nope, its job is to be the manager, making all the big decisions for the cluster, spotting problems, and responding to keep everything humming along.
So this brain, it's made up of 4 key components. And to make this easy, you can think of them as a front desk, a memory bank, a super smart matchmaker, and a thermostat, all working in perfect sync. So how does anything talk to the cluster? I mean, how do you talk to it? Well, there's only one way in, through the Kube API server. It's the bouncer, the receptionist, the single front door for everything. Every single request, from you or from another part of the system, has to go through it to get validated and processed. It's the absolute central hub. Okay, so the API server is handling all this information, but where does it all go? Where does the cluster keep its memory? That's where etcd comes in. Think of it as the cluster's permanent memory, a super reliable database that holds the single source of truth for everything. What nodes exist, what apps should be running, it's all in there.
All right, so you've told the cluster, hey, run my new app. Great, but where does it actually run? On which machine? That's a job for the Kube scheduler. It acts like a brilliant matchmaker. It looks at what your app needs, CPU, memory, stuff like that, and then it finds the best possible worker node that has the resources to host it. And finally, the last piece of the brain, and this one is huge. How does the cluster make sure that what's actually happening matches what you asked for? That's the Kube Controller Manager. It's basically a whole bunch of thermostats. It's always running in the background, checking for differences between your desired state and the real state, and then fixing.
Okay, we've met the brain. Now let's talk about the muscle, the worker nodes. This is where the rubber meets the road. These machines, whether they're real physical servers or virtual machines, are the ones that do all the heavy lifting. This is where your code actually runs.
Now, here's an important detail. The control plane doesn't just reach in and directly control these nodes. It's a bit more elegant than that. Instead, every single worker node runs a few loyal agents, and these agents are constantly listening for orders from the brain and then managing all the work locally. The number one most important agent here is the kubelet. You can think of it as the on-site commander for each node. It's always talking to the API server asking, hey, what am I supposed to be doing? And then it makes sure the right containers get started and, just as importantly, that they stay running and healthy.
Okay, so your containers are running, but how do they talk to each other? How does the outside world talk to them? That's where networking comes in, and that's kubeproxy's job. It's the network plumber on every single node, handling all the complex IP address rules to make sure traffic gets where it needs to go, so you don't have to worry about it.
Okay, we've seen all the pieces on the board, the brain, the muscle, the managers, the agents. Now for the really cool part. Let's see how they all dance together to create this incredible, dynamic, self-healing system. This is where the magic really happens. Remember that thermostat idea we brought up with the controller manager? Let's really dive into that because honestly, it is the absolute best way to understand the core principle of Kubernetes. It's such a simple idea, but its implications are, they're everything. The job of a thermostat is dead simple, right? You declare a desired state,
I want the room to be 22 degrees. The thermostat then observes the current state. It's only 19 degrees in here. It sees a difference, a delta, and then it acts. It turns on the heat. Kubernetes does the exact same thing, just for your applications. You say, I want 3 web servers. It sees only 2 are running, and it acts to start a third one. And this all boils down to a really simple but incredibly powerful 3-step loop. Observe, compare, act. That's it. This isn't just one loop either. There are tons of these little controller loops running constantly, for nodes, for applications, for everything. And that is the secret sauce to the whole system's resilience.
So let's watch this in action. Let's say a worker node just poof, goes offline. Someone trips over the power cord. What happens? Well, a specific controller, the node controller, observes this. It compares this reality to the desired state where all nodes are healthy. Then it acts. It marks the node as dead and kicks off a process to move the applications that were running on it. The scheduler then finds new homes for those apps on healthy nodes. All of this happens automatically. No 3 a.m. pager alert for you.
So that's our tour. We've seen the components, we've seen how they move in concert. Now, let's just step back for a second and tie it all together to answer the big question. So what? Why does this specific architecture matter so much? Look, the thing to really get here is that this complexity isn't just for show. Every single one of these design choices gives you a massive benefit. Having all these separate, decoupled parts makes the system incredibly robust and easy to extend. That API-centric design, it means every interaction is consistent and predictable. And most importantly, that whole declarative model, powered by those controller loops, is the engine that drives all the automation and self-healing that makes Kubernetes so powerful. And that really leaves us with one last idea to chew on. This Kubernetes blueprint, it's more than just a way to run containers. It's a whole philosophy for building systems, a philosophy that assumes failure will happen and plans for it from day one. It's a system designed for constant change and resilience. And that's a pretty powerful lesson we can apply to just about anything we build. Thanks for joining me.